Hey guys, this is Steven from the Green Engineers, and welcome to one of my update videos. It's been a long time since I've done an update video. Reason being is that a lot of stuff with school coming up on my last semester of university, and then I will be full-time work and full-time Green Engineers, and also other projects around the house and some of my other hobbies, but mainly the Green Engineers and work. So by this time, May, I already signed up for Maker Faire, so hopefully Maker Faire again, and I'll talk about a little bit about that again. I might split that off into another video. Actually, no, let's just do that here. So the idea is, last 2 years I have the signs here. I had the tool chain and the tool chain prototypes. That was the last 2 years, and then 2016 was the multi-shooter. So the multi-shooter, tool chain, and then tool chain prototypes. So this year is going to be the tool chains production. I plan on putting more time, kind of backing off a little bit on work and putting more time into the Green Engineers, more time into Senior Project, which, as you guys know, is one of the extruder, my filament extruder, the Factory, and more time into my open source version, the multi-shooter, and the shredder, as well as the Eco Base. So the two main priorities for that are the shredder, which I have my prototype here, and the multi-shooter and Factory. So Factory again has to have one of the highest priorities because it's Senior Project. I should have made the multi-shooter Senior Project, but I made the Factory Senior Project. So, but what I'm gonna show you kind of what we have open here. So on the screen. So that's kind of my idea of what I'm gonna have at this year's Maker Faire. So we are at March 4th, 2019. My cat's clawing at the door. Let me let her in. So basically that's coming up. That's May 18th through 20th, it looks like here. 2016 it was May 20th to 22nd, May 17th it was 19th to 21st, and last year's May 18th through 20th, but it's always the middle week of finals week. So for sure we're going to have the Factory done in some capacity, working and creating good filament by that time, as we need to present it to the rest of the school as our senior project, as kind of the pinnacle of our educational career in university for undergrad. So me and the group are going to have that done. Then I need to figure out a way to mass produce these guys, the shredder, as the shredder here works. I mean, I'm going to show it. I need to weld on that plate that's been outstanding for a while. So I need to weld on that plate and put a bolt, drill these, and put a bolt in here and turn them and show you guys how the functionality works. So weld it, put it down to a table, and then show you guys its operation. So, or what I'll probably just do is I might just put I might just like make a hex or something, a square that will go on this and be able to drive it with just a motor instead of having to put a bolt on it or something. Drill it, tap it right in the center, and put a bolt, because that will weaken the shaft. So yeah, the shredder, and the multi-shooter, also my open source project. That guy, I have one of his parts on his machine, and I'm figuring out a way to kind of do that and the Factory at the same time to kind of use this push towards a senior project as well. And then EcoBase, I have most of the design finished, to work on it here and there and try to get something put together with just regular open source electronics, just plug and play type of stuff. Just because the only thing that it's really innovating on is kind of taking the best of multiple things, putting it together and making it eco-friendly, making it fast to manufacture to compete with kind of the Chinese kits. That's basically it for that guy. So that's kind of what's happening now. My load has been lessened, as at university I actually dropped my CS minor so I could focus more on work and these things, as well as I actually fell behind one class last semester, so I wasn't actually on track to. It was actually going to delay my graduation if I kept a CS minor, so I dropped it. I still need to submit the paper to the department, to the registrar to have them drop that so they don't hold my graduation, because I am not going to complete it on time. I'm going to be one class behind, and because that's the case, I actually was able to remove one class, so now I'm taking 4 classes instead of 5, but I'm still working about maybe 30 something hours a week, and also some time at home working as well. So that's pretty much what's going on right now. The next thing that I'm going to be working on is sorry, I was thinking about something else. Okay. Something else came to my mind, and I thought about that for a second. Okay, so what's on the screen right now is what I have left on the multi-shooter, as well as what's going on in the filler factory. So this is currently what's going on. Again, I said what's going on with the shredder. Shredder, I still need to do this guy. I'm gonna go up to San Francisco and use the punch and die. I've talked to one of my friends who's an old machinist back in the day, a really knowledgeable guy, and he told me what he recommended for doing the that he recommends doing the die instead of the push broach. So to do a die and press in this piece and be able to look at be able to press in this piece and punch out this section. So that's what I'm going to do. Is use the push die in San Francisco and use the heavy duty machine there to press this through. So what he recommended is have one with a hole, so you could put a kind of alignment tool there, so that I could do it quicker to reclaim all of these parts for the 8 that I have that I could use, and then that will give me maybe 3 or 4 to hold, and then I'll be able to finish my water jet. And the water, hopefully those 4 last until about 3-4 months from now, and then I'll be full-time at work and full-time at out of school, as well as full-time also in summer. So at work and full-time at the Green Engineers. So they're also at work. They're very interested in using the water jet, so I could use that as well to get some time off to work on the water jet. So that's what's happening with the shredder. So now what's happening with the fill factory and the multi-shooter is what I'm doing now is I'm working on the MOS firmware for the multi-shooter. And I did recently look at what the fill factory was based on, which is Lyman Mueller firmware, which is called Mackerel. And Marlin is the main, Marlin and Repetier, but Marlin was the original main firmware that runs the most 3D printers. And marlins are bigger fish, and marlins actually eat mackerel. Mackerel are smaller fish. So the mackerel makes the filament, and the marlin's the 3D printer that eats the filament. That's kind of how it goes. But I looked at it, because originally it said it was based on marlin, and I looked at it, and it's actually legit a direct copy of marlin over, and then they changed a few settings somewhere in there to get it to run. So they kept all of like the display stuff and all that kind of jazz. I think that is definitely not the way to go. It's way bigger, harder to look through and find different things and change it, and it has way too much complexity, because I looked through it and it still has like the X, Y, and Z on it. It still has all the different types of boards. It still has all the different types of controllers and stuff, and different pinouts for different either Arduino or G Shield or whatever, or a ramp shield, or a Milzen, or what they're called, a Milzy controller, or all those kind of stuff. It only needs to run on a Mega with a ramps, or for the fill factory needs to run on like a Mega with a ramps, and the multi-shooter needs to run on just these other modules that I have. So what I'm thinking of is I'm just going to keep going with my my multi-shooter firmware, MOS, multi-shooter operating system, which is also the first 3 letters of my last name, which is pretty cool. So I'm just going to make this guy work on the multi-shooter and basically change the pinout for the fill factory. So I'm going to show you guys what that entails. One other thing that I need to do is I need to get some less turn servos for the rack on the filament. So I have been able to do that. Something just fell off of it, and I don't know what it was. Oh, it was a little nut. Okay, I don't know where that nut came from. Anyways, so I have those in. I have a few to test, so that should be way higher resolution and allow for more detail as far as the different diameters that you could pick. So that's one of the main parts, and the last remaining parts is the is putting this together, wiring it up, and then getting the firmware to work. I think the firmware is going to be harder than wiring it up. Wiring it up would probably be shorter, and then after that I have to build the rest of them, ship those out, and then ship out the extra modules that people have. And then I will try to get that completely open sourced and release all the documentation for all that kind of stuff for this project, and then support this project, which will have the same firmware and the same bones as the fill factory. So now I have an open source one that can be built anywhere with less parts, and then I have the high performance fill factory that's for the US and Europe and all the kind of developed countries, I guess you could say, that I would ship to. Okay. So basically I have the firmware here for the MOS, and it actually is 3, I don't know, this one doesn't even have anything on it, so I don't even know I have that, but it's mainly 4 main pages. So we have MOS, course cal, fine cal, and pins. And what I did today is I started adding things where I'm adding comments to stuff to show, so after a while I look back at it, I know what it is. I still have a little bit left to go, but basically what I need to add here is that pretty much I was thinking of adding a PID loop, because I wrote this back in the day. I didn't know as much as I do now, and the PID loop is basically a very simple, just if the temperature is lower than a temperature that you, if the temperature is lower than the temperature target that you want, the temperature current is lower than the temperature target, just keep going. And then once it overshoots a certain hysteresis, then turn off, and then let it fall down past that point, another hysteresis. So it's actually like 4 degrees now. Currently I have a 2 degree hysteresis. So that way it will extend the life of the SSR, and it will just kind of bounce up and down these 4 degrees. Because then again, this thing's got steel tubes, so it's got a pretty heavy thermal mass. So it's not that big of a deal if I let it vibrate a little bit as far as temperature, especially with the diameter control. So this will extend the life of the SSR relay because of the actuations are not as often. So thinking of changing that PID, but it's not as important, so I'll probably keep that the same. The next thing is to actually get the, this is from a scale. I haven't went back in and changed the comments on that. So this guy is going to use our analog variable linear motion potentiometer, which is an analog, and I have the new design for that. Let me actually open that in another tab while we're going. I actually have it printed right here, so that's ready to go. I'll show you guys how that works. So then read RPM, probably not going to use this. It's not that big of a deal that you know how many RPMs the thing is moving. Again, we only have a 2.8 inch display. We needed to have as much on that display as possible to show you basically how long it's going to take for the kilogram to finish. So this is not really that big of a deal. Automatic algorithm, this was like old, so the automatic algorithm needs to be changed. So I was thinking about doing heat, but I think heat might be a problem, so I'll probably just do the motor, but that means that we only have 0 to 255 selection. So if it's anywhere like plus or minus a few speed, I don't know if it'll have really the resolution to get tight filament, but on the multi-shooter, that's kind of how it is. It was never intended for super high tolerance filament, while the Factory is designed for that super tight performance, and that's why it's going to be using a stepper motor instead of just a servo motor and a regular DC motor. So that's what you see here. It goes from 0 to 255. The manual algorithm, that's going to be dropped out. And then here you see some of the stuff that came from the filament winder system. So this is all the stuff for the filament winder system that's just been copied and pasted, and everything's been put in there. So basically I have this guy in, so this guy should be working for the servos, just copy and paste. I need to work on the auto, which is the diameter controller. So I need to work on, for that I need to get the reed filament, and then I need to add this, and obviously this is gone. So those are the two things that I need to do. And I need to make sure that all this has error, that all these errors are gone, and that I have all these libraries. Check it, make sure it works, do any updates, compile it into a hex, and then basically upload it to all the Arduinos that I need to push out. And I believe that we have that the TFT screens that I used at the beginning are no longer being used, or no longer being sold, so I'm going to have to phase those out. So they have one here where basically I think you just flip these two variables because the coordinate system is actually flipped on the screen for the resistive touchscreen. Okay, so let me show you guys really quick on the new dimensional control. Okay, here it is. So, sorry, it's 12:30 in the morning. I gotta wake up at 7:20, so I'm going to finish off this video here in a minute or so and then jump in the shower. Alright, so basically what I decided to do initially, this is what it looked like. And I actually have a functional version here in front of me, but it's not that functional. I'll show you in a second why that is. Do I have the original version? No, I don't. Okay, so basically what happened, I'll show you just with this. Okay, so how this version is here on the table, this is the LMP, linear motion potentiometer. It was in this hole, and then this shaft was directly attached to this guy, and this guy is spring loaded. There's a spring that actually goes right here, and it would ride this shaft back and forth, and this guy is so sensitive that it would read that back and forth, and while the filament is riding between these two diameters. So that way it'll be able to sense the diameter. Now the problem with that is that this linear motion potentiometer is very fragile, so this shaft is not very strong. So basically what would happen is, I have it right here, is it would just kind of flex whichever way, and this thing's got to be extremely accurate. So it cannot have any flex at all in the shaft. So because of how far it's outstretched and how much moment it has on it, and the filament is not perfectly controlled to come straight down, it was causing a lot of issues with reading all over the place. So basically what I'm doing now is I added this bushing here with this rod, and we're going to be making this bushing out of ultra high molecular weight polyethylene. And then this is a steel rod that rides on the inside of this self-lubricating ultra high molecular weight polyethylene bushing, and it's attached here with a spring as well, and it has a very long throw, as you see here, very long, so to get rid of a lot of the moment. And here's plenty of 5 millimeters, I think, or something. There's probably a little bit more than 5 millimeters of room here. And then this guy spins in here, so this spins until this, so you could actually adjust, because this shaft spins. So you could spin this guy to adjust it, so when it's bottomed out, it actually reads 0 on this, and then as it moves, it will read. So this will allow you to zero this out. and get the full resolution of 0 to 1024 and get really high resolution on the filament. So this guy, I have it currently printed here. I need to make the bushing for it, but the sensor pushes in there nice. It's all ready to go and make one of these work correctly. So after that, and if this guy works perfectly in the field, and that's with actual testing, not with using just a mill and bumping up with it with the with the spindle, because that's obviously a very, very isolated incident. But if we could properly predict 1.75 millimeter filament that I have laying around, then I'll buy a whole bunch of these, which are $10 to $15 a piece, and then install them on make a whole bunch of these on printers and install them in there and get them calibrated and set up and ready to install. And this is going to be similar between the multi-shooter and the Filafactory. Obviously, the Filafactory is not going to have this. The multi-shooter has this, so it'll attach to the bar that comes in. So that is basically what I have going on for the multi-shooter and the Filafactory. So obviously, both of these need to work. I'm using that kind of design for both the Filafactory and the multi-shooter. Alright guys, thanks for hanging out for this video. I know it's been a long time, or this, I guess, yeah, video and kind of blog style, or audio style. Thanks for hanging in there, and I will definitely be doing more of these more often. It's just that things have been pretty extreme with senior project and work and school. Alright guys, thanks for listening and watching, and I will be talking to you guys very, very soon. Take it easy. Peace.